Okay, let's start chapter 9, timer or counter structure. Clock generator is so important for you because we use the clock pulse to counting in the timer structure. What about the clock pulse? As you know, to get a clock pulse, we need a crystal and also two capacitor connected to the X-Tol2 and X-Tol1. Okay. All of the timer operation is related to this crystal or crystal frequency. Of course, we have a limit for the microcontroller. For example, for the 1851 based microcontroller, we have 16 megahertz crystal limit, and our microcontroller, this limit is increased up to the 24 megahertz. What is mean clock pulse for the timer, or what is the machine cycle? Okay, we talked about before, but we don't give any detail about it. Machine cycle is important for the timer structure. Yes, we know this. For the standard 1851, one machine cycle consists of 12 oscillator periods. Okay, in this figure, we understand this. One machine cycle is equal to the 12 oscillator periods for standard 1851 based microcontroller. What does it mean for us? For example, if you have 12 megahertz crystal, okay, it's mean one oscillator periods 1 over 12 megahertz, right? So times 12, it's mean one machine cycle. So this is 1 microsecond, for example. What does mean also for us? We have many commands for the 1851, and most of all them has 12 oscillator periods time consuming. So with the 12 megahertz crystal, you can do 1 million instruction per second for the 1851 based microcontroller. It is important to say that. And what about the time for the executing command? We have an equation here. T is equal to cycle mean machine cycle, 12 oscillator periods obtained from here, and crystal frequency. For example, if you have 3 machine cycle commands, you will write here 12, and you will write your crystal frequency. It can be 20 megahertz maybe. You can get the time value which is required for the executing this command with this equation. For example, in here another command, move R0 45 hex. It means the data in the 45 hex is loaded to the R0, and this command consumes 2 machine cycle time. Maybe we can check it with the command table, instruction table. Where is instruction table? It can be maybe used 140. Yes, move destination is RN, as you see, and source is direct address, right? Yes, as you see, this command consume 24 oscillator periods. It's mean 2 machine cycle. Okay, we have to turn back again. Yes. Okay, for this command, if you use 12 megahertz crystal, you have to need 2 microseconds okay, executing this command. Because we know this command is required 2 machine cycle for the executing, and if you use this equation you have to write 2 machine cycle, and we know 12 oscillator periods 1 machine cycle, and this is the crystal frequency, and you will get 2 microseconds required for the executing this command. Yes. What about our microcontroller machine cycle? It is the same with the standard 1851. It means one machine cycle is 12 oscillator periods. So we can use the same equation, okay, times with 12 of course in here. But for our microcontroller we have also an option, it's mean times with 2 option. We can do this with the hardware or software. What it mean? Your machine cycle can be is in 6 oscillator periods. We know this for the standard 1851 based microcontroller and also our microcontroller. One machine cycle is 12 oscillator periods, but with this option times with 2 clock option, we can do our machine cycle in 6 oscillator periods. Okay, it means actually 2 times faster from the original one. So for the same operation, for the same command, if you use 24 megahertz crystal, and you can use this equation again, we need 2 machine cycle for move R0 and direct address. We need 2 machine cycle, and 1 machine cycle is 6 oscillator periods with the times 2 clock option, and our frequency 24 megahertz, which is maximum value for our microcontroller. So you will get 0.5 microsecond. For the same operation, what about the 1851? What is the minimum time for the 1851? 2 machine cycle again, 12, this is not changed for the standard, and also the maximum value of the crystal is 16 megahertz for the standard 1851. It's been you need 1.5 microsecond for the same operation 1851. So you can say our microcontroller is faster than 3 times from the standard, 3 times faster for any command. But we have to know this. For our microcontroller in the development board, we have 10 megahertz crystal, okay, installed. So for this lecture, we accept this. 1 machine cycle is for 12 oscillator periods is 1.2 microsecond, because our microcontroller has 10 megahertz crystal. Or if you use times 2 options, so 1 machine cycle for 6 machine cycles, sorry, this is not machine cycle, it should be oscillator periods, okay. Your time for the machine cycle 0.6 microsecond. If you ask any question about the timer, you will accept this value. 1 machine cycle is 1.2 microsecond for all question. But if you specify this, 1 machine cycle is 1 machine cycle is 6 oscillator periods with times 2 options. So you have to use 0.6 microsecond. Okay, let's continue. What about the timer counter? Why we use timer? In microcontroller based application, if you need a time delay or you want to do some operation with the time interval, with some time interval, okay, so it's mean you have to use time operation. So you will do this operation by using the timer unit. What about the counter? Counter is the same logic actually with the timer. Timer counts the clock pulses, but counter counts the external logic signal from the physical world, not the inside of the microcontroller. This is only difference between them. Timer counts the clock pulses, but counter counts the logic signal from the external world, not inside of the microcontroller. This is only difference between them. Yes, what is the features of this? I will say after now timer counter as TC. Okay. TC is a single device. It means you can use timer or you can use counter, not both of them at the same time. If the TC starts, count from downward to upward. Counting operation from 0, 0 to 0, 1, 0, 2 and blah blah. Downward to upward. Yes, if desired, counter can be started with an initial value. If you load any initial value to the counting register, you can use this option also. So your counter start from this initial value. In this case, counter is counting up from the initial value. Let's continue. The timer or counter unit can be used as either a timer or counter. I said before, you can use a timer or a counter at the same time. It uses the same hardware as shown below. What is the advantage of using timer or counter? CPU not consume the energy by using the counting operation. Okay, CPU only interested in the software. So if you require the counting value, you have to write a comment. When you see the related comment by the CPU, then CPU is interested in. That's all. So not consume the energy from the counting operation also. This is the simplified block diagram for the timer or counter unit. As you see here, we have oscillator clock pulse here, and here we have a logic signal from port 3.4 for the timer 0. Okay, T0 means timer 0, and port 3.5 for the timer 1. Okay, from the external world, so we can say counter. From the internal, inside of the microcontroller, we will count the machine cycle or clock pulses. So this is the timer for us. Yes, as you see, we have a switch here. You can choose one of them at the same time. Okay. And for the counting value, we have two registers, THI, TLI. I can be 0 or 1 for the standard. Yes, TC0 and TC1 have 4 different operating modes. Okay, and operating mode should be properly set up in order to be used properly. How can you choose the operating mode? It depends on the question. This block diagram for important for us. Okay, what does this mean? We have some setting register to use timer or counter units. What are these? T mode and T con. The low nibble or the T mode, as you see, this block diagram belongs to the timer and counter unit. TC0. Okay, belongs to the TC0. So the low nibble or the T mode is related to the TC0. Okay. What about the T con? The fourth and fifth bit of the T con is related to the TC0, timer or counter 0. Yes, what is mean this block diagram? Let's check it. For example, in here actually we will choose the input source, checking the input source. How can we do it? If your this bit is equal to 0, what will be happen now? In here we have a 3-state buffer and the control input will be 0. So it's mean this path is disabled. Okay. Let's continue from this path. In here we have an inverter before the buffer, control input of the buffer. So it's mean logic 1. The control input of this buffer will be logic 1. So this path is enabled. Your input source now clock pulse. We know it. It's mean timer. So when you choose 0 for the CT0 pins, it's mean you will use timer. What about the other options? It can be 1. You will write it 1. What is now? The control input of this buffer is enabled. So this input is going to the output as like that. What about the other side? Yes, the other side we have an inverter. So the control input will be 0. This path it is disabled. So your input source from the external world, as you see, port 3.4. This is the counter mode. What about the others? M0 and M1 is about the mode selection, so I will talk about later, not now. What about the other bits? This is gate 0. Let's check it. What is the way for this pin? Yes. If you enable this buffer, the counting value will be increased up, right? So your input, according to your input, counting value will be a start according to the this enable bit. So what is the enable bit for us? It should be here 1, we know it, and in here we have an AND gate. So both of the input should be 1. It should be 1. It means in the T-con register we have a bit which is TR0 should be 1 for the starting timer or counter. Okay. What about the other input? Yes, this input is also B1. So we have an OR gate here. As you know, for the OR gate, one of the input is equal to 1, so the output will be 1. Let's check it. Gate 0 is 0. It's mean in here we have an inverter, so the output will be 1. So now this path is not important for the starting or the timer or counter unit. If you write 0 for the gate 0 and with the other settings, for example TR0, your counting value will be start. What about the other options? This pin also be 1, so the inverter output will be 0. If you want to get one value from this gate, so this input should be 1. It means, let's continue from this path. As you see in here, we have a pin, port 3.2. It means your timer or counter unit start with external signal. We can say this hardware. Your timer or counter unit start with the hardware. But if you write gate 0 as 0, so your timer or counter unit will be start software, not hardware.